So I'm going to discuss about the Jordan lemma. This Jordan lemma is a useful tool while solving the complex problems, complex integrations. There are two Jordan lemma statement. One is the simpler version. The first version is for any positive r, this inequality holds the integral of e to the r sine theta d theta over the integration from 0 to pi is less than or equal to pi over r. So first, to prove this one, we split the integral. The integrand here, we split this um, as like this one. So first, 0 to pi is splitted into 0 to pi over 2 and pi over 2 to pi. So the integrands remains the same. And in the second integral, we substitute pi minus theta by t. So, it becomes dt equals negative d theta because the derivative for pi is 0. And then now sine theta will become sine t because sine pi minus theta equals sine theta, which is equal to sine t. So the second integral now becomes from pi over 2 to pi e to the negative r sine theta d theta. This is equal to, we convert theta into t. So the lower value will be pi over 2, and then upper limit will be 0 now, and e to the negative r sine t, and d theta is converted into negative dt, which is equal to, so if we take the negative sign in the front and replace or interchange the limit, and then negative times negative would be positive. So our final result will be integration from 0 to pi over 2 e to the negative r sine t dt. Therefore, the initial integral now becomes 0 to pi e to the r sine theta d theta. This is equal to 2 times, because one is 0 to pi over 2 e to the negative r sine theta d theta, plus this second integral is similar to this one. And because this t is a dummy variable, we can replace this t by theta. So these two integrals can be combined, and it will be 2 times 0 to pi over 2 e to the negative r sine theta d theta. So we have a useful inequality to find the integral here. 0 to pi over 2 e to the negative r sine theta d theta, we have a useful inequality. Let's go to this inequality first. So take interval, the closed interval from 0 to pi over 2. And in this interval, sine theta is a concave down. Sine theta is concave down because the derivative of sine theta is cosine theta. And second derivative of sine theta will be again negative sine theta, which is negative. That's why sine theta is concave and down. So if we take a chord from the origin to the coordinate pi over 2, 1, then we'll get a straight line whose equation will be equal to y equals 2 over pi times theta. So here is a graph. So we have a chord represented by the blue line, and the equation of this curve is y equals 2 over pi times theta, and this red curve is the equation of sine theta, y equals sine theta. So if we take the sine curve from 0 to pi over 2, then we will get this red color part. Okay, so from here, we can obviously say that sine theta value will be greater than or equal to 2 over sine theta will be greater than equal to 2 theta over pi. So in the range 0 to pi over 2, this inequality holds. So sine theta is always greater than or equal to 2 theta divided by pi. So our integration is this one. The initial integration is this one. So we converted into 2 times 0 to pi over 2. And then we have this inequality, sine theta greater than or equal to 2 theta over pi. So we can use this inequality. So from this inequality, multiplying that inequality by -1, that will flip the inequality sign from greater than to less than or equal to. Since exponential function increasing function, e to the negative r sine theta is always less than or equal to e to the negative r times 2 theta over pi, which in turn will be e to the negative 2r theta over pi. So our integral now will become 0 to pi e to the negative r sine theta, there theta is less than or equal to 2 times 0 to pi over 2. And then we replace e to the negative r sine theta by less than or equal to e to the negative 2r theta over pi. So to calculate this integral, e to the negative 2r theta pi d theta from 0 to pi over 2, we suppose this constant 2r by pi, 2r over pi, and this multiplied by this variable theta is t. So that dt equals 2r over pi d theta, and the value of d theta will be equal to pi over 2r times dt. So the 2 times 0 to pi over 2 e to the negative 2r theta over pi d theta is equal to 2 remains the same. And now this theta will now convert in terms of in the integrand now is in terms of t. So replacing this theta in terms of t, we have e to the negative t multiplied by this d theta is replaced by pi over 2r times dt. So pi is a constant. This 2 and 2 cancels out. So r is a constant, it comes out. So now integral is 0 to r e to the negative t dt. So by integrating this e to the negative t over -1 and taking the limit, so we have 5 over r multiplied by 1 minus e to the negative r. So as we know that 1 minus e to the negative r is always less than or equal to 1. So we have this inequality. So this is less than or equal to 1. That's why this total value will be less than or equal to pi over r. So our initial integral will be less than or equal to pi over r. So the integral of 0 to pi e to the negative r sine theta d theta is less than or equal to pi over r. So this is the simple version of Jordan lemma. So we have the general Jordan lemma, which is very useful while solving infinite integrals in complex analysis. So the statement is when we have R0, a positive quantity, positive number, and angles theta 1 and theta 2 lies between 0 and pi. Here we for simplicity, we take theta 1 is less than theta 2. For R greater than R naught, we suppose sigma sub R is a circular arc, which is given by the set of all complex number of the form R e to the I theta. And this theta lies in between theta 1 and theta 2, which in turn lies between 0 and pi. Suppose we have a continuous complex valued function, which is defined on all arcs sigma sub R. And we suppose the maximum of all the magnitude of fz, where z is taken over the arc as the symbol mr. So if our hypothesis here, by taking the limit when r tends to infinity, mr equals 0, then for all positive s, we have this condition holds. The limit of r tends to infinity, the integrand over the arc e to the is z fz dz is equal to 0. So before I begin the proof here, let's construct a diagram as mentioned in the statement. So we have a complex plane here with the x-axis on the horizontal axis and y as vertical axis, and theta 1 and theta 2 are in counterclockwise direction as shown here. And we have the counterclockwise direction arrow here that represents the arc from theta 1 to theta 2 by the solid arc, and the rest is denoted by the dotted arc. So we are taking this arc in the upper half plane. So we know that the exponential of a negative quantity e to the negative SR sine theta is always a positive quantity. So its integral increases if we increase the size of interval of integration. That's why from integration from theta 1 to theta 2, e to the negative SR sine theta d theta is always less than or equal to the bigger interval integration. So 0 to pi is bigger as compared to theta 1 to theta 2. So this is the integral. This is the known fact. Now we parameterize the sigma sub r by gamma theta, which is given as r e to the I theta, where theta lies in between theta 1 and theta 2. Then the derivative of this gamma theta is denoted by gamma prime theta, which is equal to I r e to the I theta. And taking the absolute value or magnitude of this complex number, uh, I e to the I theta will be equal to 1, and it remains r. So the absolute value of gamma prime theta will be equal to r. So for all s positive, we note that the absolute value of e to the isg is equal to e to the s r sine theta. We derive this by taking into consideration z equals r e to the I theta. So we will use this stuff later. So before here, we need a definition of path integral or contour integral. So we have complex integral here, where a path is denoted by gamma in the closed interval a comma b. Then the integral over gamma fg dz is equal to the contour integral gamma is replaced now by the limit from a to b, and function of gamma theta, gamma prime theta d theta. So this is the formula. It will be useful. Okay, now taking the absolute value of integral of e to the I s g f g dz over the arc sigma sub r, which is less than or equal to, by using the triangle inequality, this is less than or equal to integral of sigma r absolute value of e to the isg and we can replace this e to the isg by e to the negative sr as represented here. We can replace by e to the isg by e to the negative sr sine theta, and we can replace this fg. We can separate this fg is replaced by r e to the I theta, and as previous, we got the value of gamma prime theta in terms of absolute value is equal to r, and then theta remains the same here. So this quantity will be less than or equal to r mr. This mr is taken as the maximum of all the functional value on the arc. So this is less than or equal to r times mr, and the integral is the same, theta 1 to theta 2 e to the negative sr sine theta d theta. Since e to the negative sr sine theta d theta, sine theta is positive, and this theta 1 and theta 2 lies in between 0 and pi, we have this quantity, this inequality here from theta 1 to theta 2 is smaller in compared to the interval of integration here and 0 to pi. So by taking the absolute value sign, we get this inequality 1. We use the triangle inequality and then above calculation here. So from basic Jordan lemma, we use here the basic Jordan lemma from 0 to pi e to the negative sr sine theta is always less than or equal to pi over the coefficient of sine theta here, what we call here is sr. we need to consider here that S is positive and R should be also positive. So if you plug this value in this integral inequality 1, then we will get the absolute value of this integral is less than or equal to R times MR times pi over SR. So this R and R cancels out. So we have here pi over S multiplied by MR. So by the hypothesis, the given when R tends to infinity and MR is equal to 0, that means the maximum value of absolute value of function f is equal to 0. That means if this limit holds, then 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 this right hand side approaches 0. Similarly, this absolute value on the left side approaches 0. That means R tends to infinity. The integral of sigma sub r e to the isc fg dg is equal to 0. So which is the generalized version of a Jordan lemma. So by using this lemma, we can calculate the integral, for example, from 0 to infinity sine x divided by x dx. So here's a note that this result is uniform in the argument of the arc as long as this theta 1 and theta 2 lies in upper half plane from 0 to 5. It is because the estimate depends only on the maximum value of the functional absolute value function and the universal bound for Jordan lemma. Thank you.